All right. Dear guests, for our next session, we are pleased to introduce two speakers from Optalio. Optalio is a startup which is driven by the idea of digitalization and automation for small and medium-sized companies in the manufacturing sector. First, I would like to welcome Laura Hoover, Chief Operations Officer at Optalio. Laura has a degree in business administration with a specialization in supply chain management and business informatics. She's an expert in process automation and optimization, as well as agile software and project management. And I'd also like to welcome our second speaker, Katrin Rose. Katrin is a senior software developer at Optalio and responsible for data analytics, software testing, as well as product development. She's a mathematician and specialized in machine learning algorithms. Before we start, just a quick note from my side. Questions can be asked throughout the presentation at any time in the chat box. We will collect all questions and answer them collectively in a short Q&A session at the end. But now, once again, thank you both, Laura and Katrin, so much for being here today. And with that, I'll pass it on to you.
Thank you, Matthias. I'd like to welcome you to our Impulse session, and we are very happy that you are here and that you are listening to us. Hopefully you have a nice time. And we would like to introduce you to big data in manufacturing. We are, like Matthias mentioned, Laura and Katrin. And yeah, I can skip that part, but a few words to Optalio. We are a software as a service provider for small and medium-sized businesses, for the manufacturing businesses. And our customers are typically not that digitalized. And so the first question they are asking is always, how much will it cost? How much I have to invest? And yeah, we would like to answer that question. But first of all, we want to talk about data in manufacturing. So what is data in manufacturing? Because there are a few specific data topics which are not that common in all of the businesses. And so in the manufacturing businesses, we have the machine sensorics, we have process data, we have product plans. So we need to know which work steps we have to do in which order, and how much time does it take to do a certain work step. We have inventory informations like which materials are on stock and which materials should be ordered. And then we have some general plant information like which part is in which location installed in the plant. And then we have some other information like market trends or weather information or Google buzzwords. And so big data comes in the machine sensorics and in the process data. Machine sensory is very high frequent data. So we talk about lots of data, like terabytes of data, which are produced in a very short time. And we have the process data, where we have a lot of transactional data. So everything is saved there, and it's really a big topic. And so what does it have to do with the fourth industrial revolution? Basically, the fourth industrial revolution is big data. It's all about digitalization. It's about intelligent and integrated systems in manufacturing in order to optimize the whole supply chain. And if we talk about the fourth industrial revolution, we have to talk about the Internet of Things, where we have machines which are connected, which have sensory, and which are integrated in a network of the company. So the machines can basically talk to each other, they can exchange information, and they can react on each other. And they can, of course, give information to the producer, to the person who's in charge. And if we have this common sense that we have the machines, they have sensory, they give lots of data, lots of information to the plant owner, then we can talk about machines who can learn. And the idea is they can adjust in time and react on events. For example, if there's a failure, they can learn from it, and we want to change their behavior so that when we see such a pattern in the next time we want to react differently. And so the big aim is to learn, to make the machines learn from their mistakes, and to improve the whole system, to improve product lines. And so the plant owners, they need to digitalize everything in the plant in order to improve their whole system and to be ready for the future. So I think Laura will tell you a little bit more about that, and which possible things you can do with it in the future.
Thank you, Katrin. So we learned now what kind of data we do have in the manufacturing industry, and what is big data in there. And then the question is, how can big data help? And obviously, simply collecting data and having data is not an end in itself, but it is rather the means to have the capability of analyzing it. Because with the data analytics, we can analyze the state and conditions of the machines in the manufacturing industry, for example. Then we can identify patterns, we can find anomalies, and we can also calculate the probability of the occurrence of certain events in the future. And the more complex a problem is, the more different scenarios are possible, and the more variables you have, the more important it is to have accurate and vast amount of data, so that your results are also reliable and robust. So for in the manufacturing industry, then all this kind of possibilities for improvements that can be detected by data lead to not only improving their own efficiency and their own processes, but maybe also to innovate the whole process, depending on the learning of the machines Katrin mentioned before. So it is important, and especially if we want to leverage the full stack of the technological achievements that we do have right now, and of the know-how and solutions that are in the market. And here I speak mainly about AI. You probably have heard of it before during this session here and during the tech conference, because when we talk about big data, we talk about AI. And the reason for it is that artificial intelligence is depending on big data. And here I would like to take a little detour with you to further explain why this is the case. So in traditional software development, usually you have a certain problem, and this is handed over to a developer who then thinks to how to abstract this problem to come up with a program which then finds the solution. So for example, you want, for any reason, differentiate sheep and cows. So this is then handed over to the software developer, who thinks about how to abstract this. And maybe she comes up with saying, okay, the fur, the size, and the weight makes a difference. And so when you then have an animal which has a straight fur and weighs more than 600 kilograms, the program says this is a cow. Which means we have a code, and the code is more or less the program that finds the solution to this problem. In AI, it is not about having a program which solves one certain problem, but instead the problem is handed over to, this time it's not a developer anymore, but a data scientist. And this data scientist thinks about how to best come up with a program or a code which learns how to differentiate between these two animals. So you have a code, and then this code needs to learn. And this more or less works the same way as it does with children. So you have a toddler, and you wanted her to be able to differentiate between the animals. So you show probably either the animals or the pictures. And after one or two examples, the child usually knows one is the cow and one is the sheep. Unfortunately, machines take a little bit longer. So one or two pictures usually are not sufficient. So you have to feed them many pictures, and especially make sure that they are also have a big variety of pictures, because the dimensions are not determined, which means for example, if you only show or you only have pictures of sheep in a pasture and pictures of cows in a stable, then the program might come up with the result that every animal in a stable is a cow and every animal in the pasture is a sheep, which is obviously not the case. So it means that you have the code. You then need to have a big amount of different data, so that that together builds the program. The benefit of it is, however, that if you change the data, the code still can differentiate then, for example, between ships or airplanes or whatever kind of differentiation problem you give this program. So why did I take this little detour with you? It is to really show the meaning of big data for AI, and the AI is again important, of course, for the optimization and improvement of efficiency in manufacturing. Because for some examples, it might be sufficient to simply have statistical means or let's say simple algorithms to come up with certain improvements. But there are areas, especially when we talk about predictive analytics, where AI is really a game changer. So here it is again about calculating the probability of the occurrence of an event. It's like a weather forecast, for example, where you say how certain it is, or with a certain probability, a machine will fail. And based on this data, certain actions are possible. And it is not a reaction to the incident anymore, but you can proactively do something. So this is why this is so important. And maybe you think, well, this is just a drop in a bucket. But think about a huge steel processing company. Usually they have a straight dial to the power suppliers, because their consumption is so high that they usually inform them in advance if they want to fire up their furnaces. So in this case, if you have a failure or a downtime or whatever kind of incident they might occur, it is all completely wasted. And so these kind of uncertainties, these kind of inefficiencies you can detect with AI, and are immense also in this industry. So think about what other processes are related to it, like technicians and the maintenance cycles, like spare parts logistics, like every kind of transportation that is related to it. So it means that data analytics, and especially big data analytics, help the company to improve their own processes, which directly also improves the carbon footprint of this company, because any kind of additional resource is also a resource used, and so a drawback for the ecological footprint. So the more sufficient a company can work, the better it is, and especially reducing the consumption, reducing waste, reducing any kind of resource consumption. Not yet. Reducing any kind of resource consumption is helping the company itself to improve on their ecological aspects. But not now. Think a little step further, because now we were focusing on the manufacturing company itself and how they improve internally. But we have OEMs, which obviously also produce for other businesses. So it means that whatever kind of sensors they install in their machines, they can also be used for further purposes in the downstream businesses. So Katrin explained beforehand that there are machines which have the sensors so that they can, first of all, measure the states, but they can also talk to each other, so that these systems and machines know what is going on the other side of the field, or wherever of the production plant, wherever we are talking about. And this is something where the manufacturing businesses or companies can also influence the downstream companies. And now you can switch to the next slide, please. Because here is an example where they use, so for example, AI and big data is vastly used in the US in the agricultural sector, for example. So here you have little sensors which are installed in the harvesting machines and tractors and any kind of agricultural vehicles, and that are used then to measure the environment. So temperature, humidity, and every kind of crop health, and I don't know, insect and fungal infestation, and name it. And based on those findings, together with the weather forecasts, together with, again, external big data, conclusions can be drawn and analytics can be made, so that you, again, minimize the effect it has on the environment, like reducing the need for chemicals, because you do not have to directly put it on the whole field, but you see the spots where it is needed. And it's the same with the water. So it's not like you need to flood the whole field, but you see the dry spots in the in the field where it is needed. So in a nutshell, it means that first, with the big data that is produced within the manufacturing industry itself, they can improve their ecological footprint. And the more application areas, of course, they find, the better it is to, or the greater impact they have, obviously, on the ecological footprint of their company. And not only do they improve their own footprint, but they are also empowering others, downstream companies, to do so themselves. And if this is not enough, so we can't probably avoid the climate change anymore. But big data also helps to better handle the effects, because with less use of resources, with better predictions and forecasts of natural disasters, it is possible to proactively take countermeasures instead of waiting for it to occur before handling. And also to optimize the crop yield, so that a higher population can be fed from a smaller agricultural area. So all in all, big data helps, of course, and it can be also used in well, mitigating the effects of the climate change. However, again, as usual, it is expensive. So companies need to invest in hardware, in R&D, and in data science, which is why we would like, as Impulse, you to think about, is it really the company which is responsible to make the data available and then to really use it for the greater good? Thank you.
Thank you very much for this very interesting presentation about the usage of big data in the manufacturing sector. And taking a look at our chat, we have two questions. The first of all is from Sebastian, who is asking if there are any risks of big data in AI, because you told us a lot about that the automation or the basis for automation is the vast majority of information which is available, which also makes it attractive for cyber attacks. So are there any risks, and what could these, or how could you mitigate those risks in the manufacturing sector?
Yes, of course. So I simply thought, Katrin, you can jump in if I forget something. Of course, there is a risk. So cyber security, I think, is a topic everywhere. And so data protection is also necessary. Here, again, the question is, when we simply talk about the manufacturing data, it is probably not really about personal data or intellectual property. So it is not really the most dangerous data for others to have on hand and to use. And usually it is more about the, well, unfortunately, the main pain point for cybersecurity in every company is the people who are the interface to the network, because I think it's called social engineering or social phishing or anything like this, is the most probable entry point for any kind of virus and for any kind of cybersecurity. So obviously it is a problem, but here again we can talk about where to store the data, which kind of data is on premise, which is pushed to the cloud, and about endpoint protection, which is needed. So, but it is more about the data collection and data itself, and not to the AI. I think the problem.
Yeah,
Okay.
I think there's a risk you didn't mention. I think some cyber criminals use their skills to attack companies to get money, simply like that. And I think that's in this case it's the biggest risk for them. But there are also good solutions on the market to protect companies, very good. But a company should also invest in cybersecurity. That's that's also a big part of it we didn't mention.
Okay, thank you very much.
And maybe just one more, and I think the problem here is more the jungle of the offer that is in the market. So really to find the protection you need.
Yeah.
Okay, thank you very much. I'm just taking a look at the clock, so I would also come to this to the second question. So Fabian is interested in your opinion on the following. So he's asking, how could yield optimization of food production be transferred into a risk region like in Africa or other regions who are not at the forefront of technological progress? So are there any, is there already any progress or any development in this area?
I think so, yes. So simply saying yes, there is. So I know from this is not from a manufacturing point of view, but definitely from the agricultural and crop science production, they have definitely means to also optimize it there. So they have seeds that need less water, and that they also use the sensors there to analyze the field and to also optimize crops there. Yes, definitely.
It's called microservices. I think they are for the usage on a smartphone. There's not that much technology needed, and it's made for lower technology markets. So that's basically there.
Yeah, that's very interesting to know. So it seems like there are also solutions which make it accessible to these to regions which are not at the forefront of technological progress, as Fabian called it. All right, then. Thank you very much. Unfortunately, time has already come to an end. But once again, thanks a lot to both of you, Laura and Katrin, for being here today and for delivering this very interesting presentation on big data in the manufacturing sector. And yes, unfortunately, we've already come to our second to last presentation. And at 4 p.m. sharp, we will continue at the main stage with a presentation about trustworthy AI. This room is still open until last person has left. So if there are still any questions or if you would like to enter into a discussion, please feel free to post your questions and we will answer them. If not, yes, we have 4-minute break now and we will continue at 4 p.m.
Thanks for having us. Thanks, Matthias.
Thank you.
Thank you.